Hello. I'm David. I'm the author of Kobweb, which is a Kotlin open source web development framework built on top of Compose HTML. And in this talk, I'll explain what that means. But before we go any further, I'd like to share some real sites that were made by users, basically to showcase to you what Kobweb can actually do. I'd like to start with what I think is perhaps the most impressive and certainly criminally underviewed project here. User Shubham created a YouTube client prototype as a way to learn Kobweb. Not only that, but he experimented with some different design principles to make it even more enjoyable to use. So I just wanted to point out, if you're wondering, can I implement my idea with Kobweb or Compose HTML or Kotlin.js, is it ready? If you could implement something like the YouTube client, you could probably make anything. Now, a more realistic use case for a lot of people would probably be a portfolio site. This is a really nice way to showcase your skills, maybe a little bit more impressive than just having a resume as a programmer. And the nice thing about it is the scope is usually really limited. So if you're just new to web dev, this is like a great project to work on without having to worry about too much feature creep. If you have a project that you like, that you really love that you've developed, but all you have is kind of a plain GitHub README for it, make a landing page for it. You could really accentuate some of its strengths. Here, Core is a Kotlin DSL API that lets you work with Minecraft data packs. One of the features in Kobweb that we're not going to be able to talk about today is called persistent connections. But Dennis, who is a core contributor on Kobweb, basically when that feature went in, he went ahead and overnight made a chess website. So I think chasing fun is always a good project. We have users who have consulting sites, and they provide programming services, and they've used Kobweb to make professional websites for themselves. I think the use case that has touched my heart the most is Rodrigo. He just got married earlier this month, and he used Kobweb to build his wedding website. And finally, this presentation, I'd forgive you if you thought this was just Google Slides or PowerPoint, but this is actually a Kobweb application that is running on my computer right now. We do use a JavaScript third-party library for code highlighting, but that's it. Everything you see here is just leveraging standard HTML and CSS functionality. A little bit of a word of caution. We're not 1.0 yet, so if you're working on a project where you have a little bit of risk sensitivity, then maybe there's something to be aware of. Also, Kobweb and Compose HTML, they are not shared UI frameworks. There might be some people who came in here because they've heard about Compose multi-platform for web. They like, oh, I can make my app for Android and iOS and desktop and web. But Compose HTML is not that. That might sound like a bad thing, that you can basically have to write a custom UI that is native to the web that you can't really share with another platform. But you can still share business logic. And actually, there's some big advantages to Compose HTML, which I will go over in a follow-up slide. But first, let's talk about Compose HTML. And I think for me, instead of being abstract, I like to see the code. So we're going to start here with a simple HTML element. We have a div, which just basically represents a section on your site. And we have two attributes, ID and style. So essentially, you have an HTML element, and you set attributes on it. And then there's one special attribute called style, which you set to a string, which contains a bunch of style properties. And the idea here is that with HTML, you kind of have your layout and your functionality defined in one place, and ultimately your styles end up in a different place, so you get a nice separation of concerns. Let's look at Compose HTML. So basically what you have is you have these composables. The Compose HTML API provides them, one per HTML element. And when you call it, everything takes what's called an adders builder or an adders block, where you can use this sort of type-safe API to set attributes. And for the style attribute, they have a sub-block where you can basically get type-safe style properties that you can set with compiler protections. Now, when you do this, you get to create an element on the screen like you see here. One of the really nice things about developing with the web is you could just inspect it and bring up some dev tools. You can play with some values live. And this is like a really great way, for example, if there's a property that you don't really understand, you don't have to keep going back to the code and then try something out and then go. You can actually mess with it live, and you can learn a lot about what you can do with HTML that way. So you really get this very powerful interactive, iterative development experience. So here is the infamous CSS. Nothing here too complicated. We're just taking that style that we defined before, but we're putting it in a separate file, and we're giving it a label name here. Once you've done that, you can set the class attribute on the HTML element, and the browser will put it together. So let's look at this in Compose HTML. What you need to do is create a global style sheet object. And within that, you can declare multiple style blocks. We only need one for right now. And once you've done that, you can then, in Compose HTML, declare that you want to use that style sheet and then reference it within your adders block. Finally, a really useful thing that comes up a lot is you have JavaScript APIs that work with raw elements. So here what we're going to do is we're going to grab the element by ID using the web standard library. You could do a lot of interesting things with it, but to keep it simple for this talk, all I'm going to do is set the opacity on it. Sure, we could have put that in the CSS styles, but still, the purpose is just to show that you can sometimes get raw access to the element. Now, when you're in the world of Compose, you're calling functions. So how do you get access to this raw element? Well, with Kotlin.js, you can call the web standard libraries, but wrapped in Kotlin. Now, I put an X here because remember, we're in a composable context. So if anything on the page changes, it's going to rerun. It's going to recompose that page. So let's go ahead and put it behind a launched effect to make sure it's only set once. Now, this is fine. This is totally valid code. But I think a more idiomatic approach is to use something called a ref callback, which Compose HTML provides in its adders block. And what this will do is it'll give you access to the raw underlying element, which you could then use. It's worth knowing that this callback is disposable, so you have to return an onDispose callback at the end of it, or else you'll get a compile error, which is why I included it here, even though it's empty. And the last thing I want to mention is maybe we had created this idea originally just so we could get access to the raw element, but we don't need it anymore since we can use the ref callback. So before, I had said that Compose HTML is not a shared UI, but maybe that's a good thing, actually. And so let's talk really quickly that Compose multi-platform for web, the way it works is you create a full-screen canvas on your HTML site, and then Compose renders to it. But that information is completely opaque to the browser. It has no idea what's on there. Whereas Compose HTML basically embraces the web natively, and your Compose instructions end up getting converted into a DOM tree, which is your HTML element tree hierarchy, and that gets passed on to the browser, and it allows the browser to render it. There's a handful of advantages for this. I think the thing that might matter to most users in practice is the smaller site download size. It's significantly smaller than Compose multi-platform for web. I think an advantage that a lot of new users will underestimate because they don't use it at first is the fact that you have a compatibility with a huge amount of JS frameworks. There's just so much code out there, and you could almost always integrate it tightly with your Compose HTML page. All right, we're ready to move on to Kobweb. So I used Compose HTML about 4 years ago, and I really loved the idea, but I found some things didn't quite meet my expectations. So that's what led me to want to put a layer on top of it. Now, one of the things is I noticed when I played around with JavaScript frameworks, they had really great library loading experiences. I think Kotlin developers, because they usually work with much larger code bases, they sort of put library loading on the back end. They don't really think about it until maybe later. But I wanted to make sure that we had a great library loading experience from the ground up. And if I couldn't have gotten something where I felt satisfied with this, I would have given up on this project right away. Routing. A lot of developers might say, hey, you can get your navigation library, and you can handle navigation, hook it up yourself. That's fine. I'm not interested in that kind of code. I'm making a website. I just want to build my website. I want to write the fun code. So Kobweb has a lot of support for just doing this for you, and we'll go over it in a little bit more detail later. SEO. So one of the nice things about having a framework that basically generates a DOM for you is that web crawlers can find it. Furthermore, Kobweb knows all of the pages on your site since it handles the routing. So we can snapshot all of these pages, and we can basically present it in a way that web crawlers can discover it, and then your site can end up on Google, which I think is important to many users. We're not going to be able to talk about it today, unfortunately, but Kobweb does have Markdown support out of the box. One thing also to mention about it is you can write code in your project, and I added a special syntax so that you can actually reference your code inside of your Markdown. So even though Markdown can feel like a convenient static format, you can still put a lot of dynamic elements on it with what Kobweb provides. And finally, my background is Jetpack Compose, and there's a lot of things I really liked about that library. So whenever possible, the web and Android are different, but sometimes there's some ideas I can borrow, and I think that they fit pretty well, even though it's on the web. Modifier, box, row, column, Android developers all know about those, and we're going to basically show examples of those in this talk. It's useful to know that Kobweb basically has 4 major sections. We've got the Kobweb binary, or the CLI. This is what you do to run a couple of commands that help manage your project. You have your Gradle plugins that bundle KSP processors, which is just a fancy way to say this is how we know about the structure of your project. So we could generate boilerplate code for you that you don't have to do it yourself. There's a Kobweb server we'll be talking about at the end of this talk. And then there's the library itself, which is probably what most people think about, right? That's the code you're actually interacting with. And it's worth mentioning that there's a subset of this library called Silk, which is sort of the Kobweb classes that are related to presentation logic. This is practically the most important slide in the talk, because if you're not going to install Kobweb, then the rest of it doesn't matter. But what we do is we support 3 major package managers to make it easy to install Kobweb on all of the major OSs. There's other ways to install Kobweb, so you can read the docs for that. But if you're willing to use one of these package managers, this is the easiest way and the way that we recommend. Once you've installed the Kobweb binary, the first thing we're going to do is we can create a project. You can run Kobweb list to see all of the projects that we provide. We have some examples. This list is going to grow over time. As a default, if you're not sure what to do, we just recommend doing Kobweb create app. This is going to create a very simple Kobweb project that basically has 2 pages in it. It's not too large. You can just create it, learn from it, throw it away, create it, throw away my content, but build on top of it. This is just a great place to start. It creates all of these files you see here. You don't have to read that slide. You don't have to worry about it. But one thing I like to point out is there's no index.html file here. There's no main.kt file here. Basically, Kobweb is creating these things for you so that you don't have to worry about doing it yourself. Let's jump into the build script, because I think there's some interesting things in here. The first thing is it applies the Kobweb application plugin, which you apply to basically say that this module is going to be what becomes your website. There's this Kobweb configuration block. We're not going to have time to talk about it in this talk, but you can really configure Kobweb quite a bit here. And so just so you know, this is where you can go if you need to tweak some default values. Inside the Kotlin block, you call config as Kobweb application. We set up some things for you. You pass in this string name. The name doesn't matter that much. Just choose something short that is generally descriptive of your site. And we'll see that on this next slide, it's going to come up again. So one of the things that's also created is this conf.yaml file. These are values that are used by the Kobweb server. When we're going to run a Kobweb site, you're going to see it's going to run on 8080 by default. This is fine, I think, for almost most cases. But if you ever needed to change it, this is where you'd find it. And here are the values that get produced by the compilation process that the server needs to know about so it can serve it. And as you can see, that we have the name app here. So if you change the app string that gets passed into your build script, you just have to make sure to keep this in sync. Running a project is easy. Just go into the folder that we applied the Kobweb application plugin on, and we run Kobweb run. So what this is going to do, it's going to build up your code, and it's going to basically put you into this nice, convenient live reloading mode. And this is when you're developing, right? You just kind of develop, you edit code, and it's just going to keep going. And then when you're done developing, you just press Q to quit the server. And at that point, what it's going to do is it'll shut down all your resources. You know, if you're just using raw Gradle commands to do this stuff, you would easily create a server and then forget that it's running and leave it running for a while. When you're done developing your project and you're ready to publish it, you do Kobweb export. Basically, this is what does the magic. It takes your Kobweb site and it visits all of the different pages you've registered and takes snapshots. This is what's really, really good for SEO. When you're done exporting, we're going to use Kobweb run again, but we're going to pass in the production environment. What this is going to do is going to bring your server up in a slightly different way where live reloading is not enabled. And this is just a great way to test that your export is actually good and ready to go. I think it's really helpful to talk about very basic project organization that you can find in your Kobweb project. There's essentially 3 top-level folders and files here that are important: components, pages, and app entry. So app entry is a place that you can think about as your main inside of a Kobweb project. It's basically a regular composable that you annotate with the app keyword so that Kobweb can find it. You take in a content callback, pretty standard compose pattern here, and just make sure you call it inside your body of the function, or else you're not going to have anything render. This is a generally good place to sort of put global configuration and maybe define some global styles for your site. The components folder, now this is a convention. You don't have to have one. You can call it whatever you want. You don't have to follow what I'm suggesting here, but we do generally recommend following this because it's a decent organization. And if you do this, other Kobweb users will be able to immediately find out where the files are on your project. So you have the layouts, sections, and widgets folder within it. Layouts are full page UI. You can imagine if you have multiple pages on your site, what are the common layouts for that? Those will go in here. But sometimes you're going to want to refactor out subparts of those layouts, and that's a really great place to put into sections. I think a nav header on the top of your site, the footer at the bottom, maybe sidebar on the side. This is a really natural place for those composables. And then I think widgets is pretty self-explanatory. It's your low-level one-off UI components. This is a basic layout, like it's a regular composable. You annotate it with layout. It's got a content callback. I just really want to emphasize here that this is pretty standard composable code that you'd write anyways, and all you have to do is annotate it a little bit, and Kobweb will take care of a lot of work for you after that. And as I said, we have sections, so you're going to import sections and call those in your layout. This is just a pretty standard, simple example of what a average layout might look like. Pages, unlike components, is not a convention. You have to have pages. If you have a page that you define in another folder, Kobweb will complain for you at compile time, because Kobweb is going to use the path from the page to this page's root folder when generating the URL for it. A page is a regular composable. You annotate it with page. You can also annotate it with layout, giving it a path to the layout that applies to it. And the one thing is you can provide an optional page context parameter that Kobweb will pass in if you do that. And I'm only mentioning it here now. It has some information about your page, and we're going to use it in a slide down the line. And finally, in your module folder, you have a resources folder that Kotlin can surface. And if you create a public folder under that, then anything under that will be exposed to your site. So Buster is my dog, and by putting this image under the public images folder, I can reference it in my image element and get a cute dog into my presentation. All right, now we are going to revisit our code samples, but we're going to Kobwebify it. So here we have the compose HTML that we created for the HTML element. Now watch this on the right. I'm going to replace this with a modifier. A modifier concept comes from Jetpack Compose. It is a chain of immutable values, and just like that. So one of the things that's worth pointing out is this is an attribute modifier behind the scenes. It's setting an attribute, and these are style modifiers. On the left side, there's kind of like a hierarchy here where the attribute is sort of one level higher and the style is sort of nested underneath. So some people might be worried that it's a little confusing, that we're kind of mixing the two concepts and putting them at the same level. But in practice, there's very, very few attribute modifiers. They're pretty easy to detect. 99% of the time when you see or use a modifier, it's just going to be a style modifier. I told you I'm inspired by Jetpack Compose. Jetpack Compose has the size modifier. There's not a size property in CSS, but I don't care. I think it looks a little bit nicer. It's concise. It's easy to read, so we brought it in. Now, Compose HTML, I said, has this attrs block. Kobweb has a modifier, but you can always convert a modifier to an attrs block by using the toAttrs function. That being said, we're in Kobweb now, so we can use box, which is provided by Kobweb. A box underneath is a div. There is some nuanced difference between a regular div and a box, but in many cases, they're interchangeable. And whenever you're working with a Kobweb method, it takes modifiers directly, so we could remove a bit of code noise there as well. All right, we're back to CSS. So if you recall, we created this global style sheet object, and we put a style in it. In the world of Kobweb, we manage that style sheet for you. So all you need to do is declare the CSS style block itself. And so you do this, you create a top-level property, you set it to the CSS style block, and within it, you declare a subset of styles. So here we have the base style. The base style is very common. It represents the core underlying style associated with this CSS style block. This will make a lot more sense too in just a moment when we see it in action. And whenever you define a style block, it expects you to return a modifier. So yeah, so back in the compose HTML case, we had to declare that we were using the style sheet. In Kobweb, you just take your CSS style variable and you convert it to a modifier and you're done. So the one thing I want to point out is you cannot put attribute modifiers into CSS style modifiers or into CSS style blocks. That'll cause a runtime exception because attributes aren't valid in a style. So in general, that's what we're doing here is keep the attribute modifiers out of it, and then you just can declare it externally like we're doing here. Raw element case. So in the adders block, they have this ref callback, but Kobweb doesn't have an adders block anymore. So all of the Kobweb methods will actually take in a ref block as a parameter. You notice here we do not need to have the onDispose call anymore. Most times you don't need it, so Kobweb opted out of using that, and they just sort of have a non-disposable version as a default. But if you do have logic that is disposable, you can do ref equals disposable ref, and then you can basically pull that back in. And then there's like a case that I use all the time, and yet it's really kind of a pain in HTML. So I thought I would showcase it here. So we just have this kind of outer white container, and we have some centered content inside of it. I'm using a sort of column and a row flow to sort of lay these things out. And the HTML looked pretty concise, but the CSS to declare this can get pretty wieldy, especially if you have to do this every time. You have to basically communicate to HTML like, oh, this is how I'm using this div. And notice here we have justify content and align items to how we center it. There's also justify items and align content, and I always forget which one applies to which axis. It's not intuitive to me, and so it's just always friction. Then you have to make sure to configure your column and your row divs. Or in Kobweb, you could just write general Jetpack compose code, right? So you create a box, you set its content alignment to center. I think that's extremely intuitive. You create your column and your row, and we're going to just do all of the nasty CSS work for you behind the scenes. I'd like to talk a little bit more about CSS style. So as I said before, you create these CSS styles with a base style. This is such a common pattern that we actually have a shortcut syntax for it, where you can remove a level of indentation. But let's actually look at a case where you can't do that, where we actually have an additional style. So here what we do is we have the hover style, which will only be applied when the HTML or when the browser detects that the user's mouse is hovering over the element. So you can see here, that's exactly what's happening. So at this point, you can read it that when there's a base style, that's always applied first, and then any additional style that's conditional is applied when that condition is met. And finally, especially when you're new to web development using Kobweb, you're going to go around and you're going to read articles, and everyone's going to present their articles to you in HTML and CSS, and you're like, well, that's great, but I'm writing Kotlin. So you can use CSS to Kobweb. You can paste some CSS inside of it, and it'll show you some of the output Kobweb code. Very convenient, especially not only just for learning, but for iterating quickly. Let's talk about routing. There's a bunch of cases, and I want to show you how Kobweb handles it. We'll start with the easiest, which is when you have a top-level page. So here, by the way, this part that's highlighted in blue, that's everything after the last slash of your route is called a slug. And so for Kobweb, they get the name of the slug from the file that you declare your page in. So here, the file is about.kt, so Kobweb is going to use the name from there. It's worth understanding that there's also your function name. Kobweb doesn't care about it at all. You can call it anything you want. However, by convention, we recommend you just repeat the file name and add page at the end of it. Common pattern as well, especially in modern websites, is you don't want to show a slug. You want to kind of make it look like you're visiting in a folder. So for that, you basically can use the index name, and Kobweb will treat that as essentially the empty string as a special case. Google SEO recommendations say that you should put hyphens to separate your words. You don't really normally put hyphens in Kotlin file names. So what we'll do is we'll detect camel case, and we'll split words based on that, and we'll put hyphens in for you automatically. All right, now we're moving away from the slug into the middle of the route. Each part of the route is called a route segment, and Kobweb gets its route segment names from the package. So here we have blog.2025. Now, it's worth pointing out that numbers are not valid package names. So what Kotlin says to do if you want a number as a package name is to put a leading underscore in front of it. So that's why Kobweb will detect any leading underscores, and it'll just remove it to generate the name. Putting in a hyphen in, it's the same thing. We detect camel case, and we'll hyphenate that for you. Now, everything so far has been the happy path. Here, we want to break free from that. We actually intentionally want all caps, and Kobweb, the Kobweb algorithm, automatically lowercases stuff. Thankfully, handling this is trivial. Basically, if you pass a string into the page annotation, that's you telling us, don't do anything, just take this, trust us, this is what we want. And now that's fine for slugs. How do we do this for the intermediate route segments? Kobweb provides the package mapping annotation, which basically will be associated with a package in your site. And then if Kobweb visits that page that's under that package, it'll apply the transformation as expected. Finally, there's a pattern that's common in modern websites here, where you can see that essentially we have like multiple pages which really all want to be handled by the same page. This is essentially the URL you really want, and this is called dynamic routing. And the way Kobweb supports this is you use those same annotations we just talked about, but you pass in a name and put curly braces, and that tells Kobweb to treat this as a value that'll absorb any input that comes in. And if you are OK with the default names that Kobweb was going to generate for that package or for that slug, you can leave those blank, and Kobweb will do that for you. Once you've done this, then you can take that page context parameter that we talked about, and in this case, you could use context.route.params to pull that information out. All right, at this point, we've covered a lot, and we actually have enough information where we can create a basic page. So what I want to show you, what I want to do here is create this kind of this Guestbook UI. And while we're still looking at this prototype, just understand we have these text inputs, and there's this like label that's kind of offset to the left and to the top. And then we have this send message button with an icon. So yeah, I want this new Guestbook page to be available at /demo/guestbook. So let's go ahead and visit it. And it's not found yet because it doesn't exist. So now we're going to head over here to the code. And as you said, because I'm following Kobweb conventions, I've got my app entry here. So I'm grounded. Here's my pages folder. So we're going to go ahead and we're going to create a new package. And then we're going to create a new file to match the slug that we want. Perfect. And then let me go ahead and bring in some code that we'll talk about. So the first thing I want to do is I want to make sure that it worked. So what I've done here is I've basically put in a placeholder stub. Notice here what I've done is I've created this box that's filling the whole screen. And then I want to center the content. And then the content is just some basic text. So let's take a look. Sure enough, it loaded while I was talking. It actually goes pretty quick. It'll go in about a second or two. So the one thing I want to mention is normally this kind of idea of like this box or this thing that's containing the whole page, I would normally convert that into a layout, but we're kind of in a constrained time environment here. So I'm just going to not put a layout in this page. It's fine. All right, let's turn this into real code. All right, so the first thing I want to show you is that I've created a composable widget, which is it's going to represent that input with a label on top. It's following the standard compose pattern where you pass a value in, and then you use an event to send the change notification out. And you can basically avoid putting state into your composable widget that way. Let the caller handle it. We have input here, which is actually a silk widget. You could tell because it takes a modifier directly. There's no tuators. And then the other thing I want to say is when you use raw text, there's like a text function from compose HTML, and that just basically does not put an HTML element into your page. It puts raw text. And you can't style raw text directly. You can only style HTML elements. So a very common pattern in the web is you wrap your text in a span, and it's so common that Kobweb has decided to basically provide a helper method for it. So that's what's going on here. And so we basically have these two widgets, and we're using a box to kind of jam them together. And here's our page. This is the same box layout as before. We're declaring our fields. This is really just some standard compose setup. And then here we have the button. We'll implement the click listener later, but we're passing in the enabled field to make sure that the button isn't enabled until all of the fields are actually set. And in this handler, this is where you basically put the text on top of the button. And notice here we're using this FA. FA stands for Font Awesome, and it's really easy to add Font Awesome icons to your Kobweb project. So we could look at it here just to show you that I mouse over here. The send message button is grayed out. It is disabled. So let's go ahead and put in some values just to make sure that, sure enough, now I can click on it. All right, we'll come back to that page later. And let's talk about Fullstack. So this is the final part of the talk. Basically, everything we've talked about so far has been front end, right? Everything is done in regular web pages. And there's essentially two layouts that Kobweb supports when you export. There's a full stack layout and there's a static layout. The static layout doesn't mean that your content is static. It just means that the layout of your files is static. You're basically taking a bundle of HTML files, you're sending it to a web hosting server that talks static hosting, and it will just serve those pages when people visit those associated URLs. And in general, you should prefer using static as much as possible. It's cheaper to host those things. In fact, like GitHub Pages, it's free. It's much faster to deploy. It's much easier to deploy. Usually with full stack applications, you have to create Docker containers and custom setup. But depending on your backend functionality, you may just need a backend. I think a really common case is you might have a private API key, and you don't want to expose that to a user. So you have to have a custom server. So in that point, let's just go ahead moving forward, assuming that we need to be a full stack application. So we're going back to our build script from before. Add include server equals true to the config as Kobweb application function. And that's going to enable the JVM target. The JVM target is going to be where the backend code lives. Whenever you go into full stack mode, I highly recommend using Kotlin serialization. It's such an easy, effective way to share data between your front end and back end. And as long as we're pulling in some serialization artifacts, Kobweb has some extension methods that we will just pull in here again as well. All right, so API routes or API endpoints, this is kind of like the back-end analog of how pages were like on the front end. Essentially, you can define a method, tag it with API. You can say that the method is suspend, so you can use coroutines. And then you give it an API context. I think you might be seeing there's a pattern that we use in Kobweb. And in this case, two relevant parts that are provided by the context are a request and a response object. The request object has information about the request that pinged that endpoint. And then the response is this mutable object that you're expected to set within the body of your API call, which we are doing here. We're just basically putting this message. The other thing I want to say is HTML standards say that endpoints should be nouns. It should be thinking about like the user is touching a resource. So that's why I use the word greeting here as well. And so once you declare an API annotated method under the API folder, Kobweb will go ahead and create a URL that you can visit. You could actually visit it manually, but normally you'll only visit it programmatically. And in fact, let's see that. So here's our API method again. Here's the front end page. So basically, the window class represents the browser window. It's provided by the web standard library. We extend it with an extension API property in Kobweb, which lets you basically target API endpoints. So here you notice we're calling get. Get is an HTTP verb. We support some the 6 main HTTP verbs from this API object. It's like get, post, delete, a few others. Notice we don't get /API/greeting because the API property automatically prepends that for us. When you call this, it's going to return a byte array, but we need a string, so you decode it to a string. So this is a pretty standard pattern. Now, the other thing I want to mention is we're putting this inside a launched effect. I mean, of course, because we only want to run this network request a single time. But more importantly, the launched effect actually is like a coroutine scope. And anytime you do a network request with Kobweb, it's in a suspend function, so you need to do that in a coroutine scope. OK, so let's talk about a more realistic, interesting example. So this is going to be a POST request. In HTTP, a POST request is basically I'm sending you some data in the body of my request, and I'm expecting you to update some value or resource on the back end. And at that point, you let me know that you did that, and it's OK. So first thing that's really interesting here is we're early aborting if we're not a POST request. So the way that Kobweb API endpoints work is this mutable response value in the context. If you don't do anything with it and it gets sent back to the client, it's going to be set in a way by default state that it's going to return to the user an error, telling them that the way they contacted that endpoint was wrong. So it is correct for us in this case, so we're going to go ahead and set the status to 200, which is an HTTP way of saying it's OK. I said that we need to get the body out of the requests, so let's go ahead and do that and store it in a message. So OK, I'm now on this random function on my server. I've got this message object. Where do I put it? So in the context object, there's a data store, which we don't use. It's for you, the user. And you can put your own values in there. So imagine that there's this messages class that you've put in there. And you add messages to it, and it'll automatically sync that to a database, right? Whatever. And we're done. So OK, we pulled this messages object out of the data store. How did it get in there? Well, you put it in there. What you do is you declare an init API method with an init API context. And at that point, you just go ahead and add it. And that'll be available to all of your API endpoints. One thing I want to call out here is inside init API, the data store is mutable. You can add and remove elements from it. But in the API endpoint, it's immutable. So you can only get a read-only view. So we now have enough information to finish our guestbook. So let's head on back, go back to the code. So here, the first thing I want to show you is in common code, I went ahead. This is just a very basic class. It's going to contain the data values that we're going to pull out of the guestbook, and we're going to use it to send it to the server. And now we just need to define our endpoint. So I want this endpoint to be called /guestbook/entries. So the first thing I want to do is I want to create a package, and we'll call it guestbook. And let me create a file called entries. All right. And so yeah, I mean, we're going to go over this pretty quick since we already went over the slides. The first thing that I want to mention is we're going to basically put some values into our data store. But the data store, you retrieve those values out by type. And due to type erasure, putting a list directly into the data store is not great. So we're just creating this wrapper class to give us something unique to grab onto. And as you can see, we're actually adding that here to our data store. Here's the POST request, which looks exactly like essentially what I did in the slide. We're reading the body, and we're grabbing the guestbook value, which is a list of entries, out of the data store and adding this new entry that we just got from the client back in it. And we're telling the client, hey, it's great, we got it. And I'm also implementing a get handler because I want to test that this worked, right? I want to post something to this endpoint, and then we'll pull it out just to make sure that I'm, really writing real code here and I'm not just pretending. So at this point, we need to update our guestbook front-end site one last time in order to connect to the endpoint that we just defined. So here you can see I'm using remember coroutine scope because, as I said, to make a network request, we need a coroutine scope. All of this code has not changed at all. But now in our button on-click listener, we make a POST request to the API endpoint. And we go ahead and we take the values from the user, and we pass it through this common data object that we made. And then, because I want to prove to you all that I actually did that, I created a temporary page where we're going to pull back the value that we just sent. And you can see that right here. Sure enough, we are using a launched effect to call a get on that same endpoint. So let's take a look, see if that worked. So I'm going to go ahead and sign my name here, Kotlin conf 25, and Kobweb is pretty nice, I guess. And there you go. So this proves that we got a full round trip. And at this point, we've done it, right? We've gone from nothing to creating an active working page on Kobweb. So let's go ahead and run through the conclusion here. First, a recap of the topics that we discussed. I also, more than these topics, I wanted to give everyone a glimpse of what it really feels like to work in a Kobweb project. Right, you're editing code, you're getting live reloading working for you, you go to the HTML page, you can inspect stuff, you get this really nice, engaging back and forth flow. And you're not really thinking about compiling anymore, you're just editing and iterating. Now, that being said, honestly, there's so much more I'd love to tell you all about. Some of the things I wanted to talk originally in this talk, and I've had to cut. There's other things that are just a little bit too advanced, wouldn't fit at all. But there's just so much. I just want everyone to understand that this is a fun framework, and we're really just scratching the surface. But we do have a docs site. If you search Google for Kobweb docs, I'm pretty sure it shows up. This doc site has all the information we talked about today and more. And also, the doc site is written in Kobweb, so you can look at the source code and learn from it that way as well. We have an active community. We have a Discord server. We have a Kobweb channel on the Kotlin Slack. And if you decide to try out Kobweb and you have some questions, please visit us, and we'll help you if we can. So I just want to conclude by saying, once you know what you're doing, you can go from nothing. You have an empty site, you can build it up, you can basically upload it, you can end up hosting it, you can have a URL. Within hours, you can hand that URL to your friends or to users, and that's really empowering. As a developer, I didn't expect, there's so many processes we go through that have so much bureaucracy, so much red tape, and none of that's here. So, I avoided web development most of my career, so I'm kind of shocked to find myself being this person who's been working on this framework now. But I find that web development with Kotlin is fun and productive. So really, I just hope that some of you, if you've never done it before, will give it a shot, and maybe that you'll find that you love Kotlin web development as much as I do. So wait 1 second. I've been waiting to do this. Let's shut down the server. We don't need it anymore. And there you go. Thank you, everybody. I appreciate it.